Okay, so let us get started with our study of chemistry. And to start with, I'd like us just to consider a proposition here. We want to consider three things: the properties of silicon dioxide, the reaction of oxygen with hydrogen, and the amount of heat released when methane combusts. And the question we want to ask about these is, which of these are studied in chemistry? So are the properties of silicon dioxide studied? Is the reaction of oxygen with hydrogen studied? And do we study the amount of heat when methane combusts? Well, I think to answer this question, we really need to come up with a workable definition of chemistry. So let's start there. So let's start with chemistry. And what is chemistry? Well, for our class, we're going to go with a relatively simple definition. We're going to say that chemistry is the study of three things. The study of, number one, the structure, the composition, and the properties of something we call matter. Okay, good. So we don't know what matter is yet, but we'll get to that in a few minutes. So part one in our definition of chemistry is that chemistry is the study of the structure, the composition, and the properties of matter. Now, a second part of that is chemistry is also the study of the processes which matter undergoes. Good. And what do we mean by undergoes, or what do we mean by processes? Well, things like reactions, and I'm going to abbreviate reactions with RXN. So reactions and maybe changes of state, other things that we may get into later in this class. Good. So that's part two of our definition. And then part three, chemistry is also the study of the energy changes which accompany these processes. Cool. These processes meaning these over here. Great. So this would be our workable definition of chemistry. Chemistry is the study of the structure, composition, and properties of matter, the processes which matter undergoes, and the energy changes which accompany these processes. So let's see if we now have enough of an understanding to answer our question. Consider the properties of silicon dioxide. Which is that something we would study in chemistry? Well, silicon dioxide turns out to be matter, and we're studying the properties of matter. So are the properties of matter one thing we study in chemistry? Yes, that's correct. So the properties of silicon dioxide we would study in chemistry. How about the reaction of oxygen with hydrogen? Well, oxygen and hydrogen are both forms of matter, and this is a reaction. A reaction is a process. So these are processes. This is a process which oxygen and hydrogen goes through. So the reaction of O2 plus H2 leading to something. Ooh, we'll learn that later. Yes, that is also a study of, that is also something studied in chemistry. And then finally, the amount of heat released. Well, heat released, that is an energy change. We have an energy change, and it's the energy change when methane combusts. Hey, the combustion of methane is a reaction, CH4 plus O2, yielding, hey, lots of heat and some other stuff. Yes, that is also something we'd study in chemistry. So this question really is kind of a trick because the answer is all of those above we would study in chemistry. Good? Okay, so that gives us our basic definition of chemistry, and let's move on from there. We said that one part of our definition is that Chemistry is the study of properties, composition, structure of matter. But what is matter? So let's ask ourselves this question. Let us consider this situation. I have carbon, green light, radio waves, and water. Which of these are forms of energy, and which of these are forms of matter? Well, to answer this question, we really have to distinguish between energy and matter, and so let us try to put some meat on that concept. From my idea, I think the universe, let's start here with the universe. The universe is really composed of only two things: energy, and of course, what's the other? Matter. Now, some really smart people, maybe the physicists and others, they might argue there's other things. I'm not sure. From a chemistry standpoint, though, it's sufficient to say, hey, the universe is only one of two things. The universe is composed of two things: energy or matter. Good. So if we can define matter, then we can define energy as something that's not matter, and we can figure out everything in the universe as either energy or matter. So what's our definition of matter? We're going to say matter is anything that has mass and plus here takes up space. What do we mean? Takes up space. That means it has what? Volume. So matter is anything that has mass and takes up space, anything that has mass and volume. What are some things that have mass and volume? How about my shoes that I'm wearing now? Yeah, my shoes have mass and they take up space. Yeah, how about my body? It certainly takes up a lot of space, and unfortunately, it has a lot more mass than I wish it had, and this summer I've been working hard to reduce that mass. Now, let's come over here and consider energy. What is energy? Well, energy then is something that has no mass, so it has no mass, and it has no volume. Wow. Is there really something in the universe that has no mass and volume? Let's think for a second. Yeah, how about light? Light. Light does not have mass. Light does not take up space. It has no volume. So light is a form of energy. X-rays. Yeah, cool. X-rays. They do not take up space. They have no mass. They are forms of energy. In fact, both of these are things that we call electromagnetic radiation. And all forms of electromagnetic radiation are energy. Okay? Now, let's go back and see if we can answer our question based on this definition of the universe. Carbon. Does carbon take up space? Does it have volume? Does it have mass? The answer is yes. It has mass and volume, so it is matter. Green light. Green light. Well, we said on the last page that light is a form of energy. What about green light? Yes, green light is just a subset of all light. It's a form of electromagnetic radiation, so it is energy. Radio waves. Well, can I grab radio waves? If I had little tiny hands, could I actually pick up a radio wave? Could I mass it? Would I see that it has volume? The answer to all those questions is really no. There is no matter, there is no mass, and there is no volume with radio waves, so it is a form of energy. And finally, water. Yes, water. Once again, if I had little tiny hands and little tiny eyes and I could actually come up close to one molecule of water, would I see that it has mass and volume? The answer is yes. It does have mass and volume, so that means it is matter. Good. So which are forms of energy? How about green light and radio waves? And which are forms of matter? How about carbon and water, H2O. Good. Moving on. So now, our next question is identify the following as either energy or matter: blue light, hydrogen gas, a pencil, UV radiation. I'm going to let you guys work on this one by yourselves. I'll give you maybe 15 seconds, 20 seconds. Here you go. Okay, I think it's enough. Blue light. Blue light. So what do we want to do to answer this question? We have to just decide, is something matter or is something energy? And we want to go back to this idea that the universe is either energy or matter. Everything that is matter has mass and volume. Energy, no mass, no volume, right? Good. So, blue light. Do you think that has mass and volume? Well, we said light was energy and green light was energy, so it only makes sense that blue light is indeed energy. No mass, no volume. How about hydrogen gas? Does hydrogen gas take up space? Can I fill the Hindenburg with hydrogen gas? Yes, I can, and then it will explode and burn to the ground horribly. But yes, it takes up space. It has mass, so that means hydrogen gas is matter. What about a pencil? Oh yeah, you can hold that in your hand. You can feel that it has mass. So a pencil has mass and it has volume, so it is matter. And UV radiation. What UV? UV stands for ultraviolet. Ultraviolet radiation. When you see the term radiation, you should start to think that it is probably electromagnetic radiation. Not that all radiation is electromagnetic, but in this case, UV, ultraviolet radiation, is indeed a form of electromagnetic radiation, meaning it is what, ladies and gentlemen? It is energy. Cool. Okay. Well, I think you have an idea of what chemistry is, at least the definition of chemistry, and I think will be able to distinguish between matter and energy. So why don't we quit right here and call it a day? All right? Okay. See you next time.